when we look at this load voltage that we have here, we see that it is a square wave, and a square wave is a complex wave. That means it consists of other wave shapes that together form this square wave when we add all of them together. Also, looking at this load voltage, we see that it is symmetrical around the x-axis, meaning that the positive half is exactly the same, or the mirror image of the negative half. And if we would go and integrate from 0 up to 2 pi here, we would have a positive area here. Let's say it's plus 1. And here we would have a negative area. And if we add plus 1 and minus 1 together, then we have 0, and 0 divided by 2 pi is 0. So the average value of this load voltage is 0. Going to the Fourier series of the load to determine the components of the square wave, we have the DC term here in the first term here, and the only people that call this the DC term are electrical engineering practitioners. And I have just shown to you that this DC term here is 0. When we look at the other part of the Fourier series, we see that there is a lot of cosine terms and a lot of sine terms. And if we inspect this wave shape of ours, we see that it is positive from 0 to pi, and it is negative from pi to 2 pi. That means that it is positive where a sine wave is positive, and it is negative where a sine wave is negative. Therefore, we can say that there will be sine terms in this waveform.